Calculus 1, BSIE 1A, Charlie Team. Before we formally start this video, I encourage everyone to stay relaxed, have focus, and let us learn more.
Good day everyone. Today I will be discussing about the derivatives of inverse hyperbolic functions. It is the mathematical functions which express the inverse hyperbolic functions represent the inverses of the following hyperbolic functions: sin h, cos h, and tan h. Thus, they are defined for real and complex numbers and are used in various fields: engineering, physics, and mathematics. Applications of the inverse hyperbolic functions have very many applications. Fields of application, especially in engineering, physics, and mathematics. In structural engineering, they are very essential in analyzing the suspension cable and arc shapes that are subjected to uniform loads as they follow a curve associated with the hyperbolic cosine or cos h. Inverse hyperbolic functions are used within the application of physics, be it wave propagation, heat transfer, or relativity. For example, it serves to find proper time or velocity addition in relativistic mechanics. Geodetic and navigational calculations apply these functions to provide distance and angles measurement for an ellipsoidal Earth model. Furthermore, the functions are applied in biological and social sciences for modeling growth rates, saturation levels, or population dynamics. They are very helpful in modeling real scenarios in athletic problems as well as in the derivative of the inverse hyperbolic sine function of variable u, where u is a function of x, is equals to u prime over the square root of u squared plus 1 times du over dx. The derivative of the inverse hyperbolic cosine function of u is equals to u prime over the square root of u squared minus 1 times du over dx. The derivative of the inverse hyperbolic tangent function of u is equals to u prime over 1 minus u squared times du over dx. The derivative of the inverse hyperbolic cosecant function of u is equals to negative u prime over the absolute value of u times the square root of 1 plus u squared. So the derivative of the inverse hyperbolic secant function of u is equals to negative u prime over u times the square root of 1 minus u squared. And the last is the derivative of the inverse hyperbolic cotangent function of u is equals to u prime over 1 minus u squared, which is exactly the same as the inverse hyperbolic tangent function of u. So these are the formulas that we are going to use when solving the inverse hyperbolic function. Let's start for our first example. Our first example is find dy over dx if y is equals to inverse hyperbolic sine function of 6x. So what I am going to do first is I'm going to write down the formula. The answer is going to be u prime over the square root of u squared plus 1. Now the variable u is whatever we see inside the inverse function. So in this case, our u is 6x. So let u is equals 6x, and our u prime is equals the derivative of 6x is simply 6. So all we're gonna do is to substitute that into that formula, and it's going to give us the answer. So 6 over the square root of 6x squared plus 1. Six x squared, that 6x times, which is so 6x, 6 over 6x squared, 36 squared plus 1. So this is now your final answer. So let's proceed to our next example. Our next example is find dy over dx if y is equals to the inverse hyperbolic cosine function of x squared. Again, our using the formula first to solve this problem. So our formula is u prime over the square root of u squared minus 1. So in this problem, u is equal to, our u is equals to x squared. Again, the variable u is whatever function inside the cos. So our u prime is the derivative of x squared. So the derivative of x squared
is simply 2x by applying the chain rule. So now we're going to substitute that into our formula. So it's going to be 2x, which is our u prime, 2x over the square root of 2 of u squared rather, which is x squared raised to 2 minus 1. So it's gonna be y prime is equals 2x divided over the square root of u squared, which is x squared minus 1. So it's going to be 2x over the square root of 2 times 2 is going to be x 4 minus 1. So this is your final answer. Let's proceed to our third example. So find y prime if y is equals to the inverse hyperbolic tangent function of, now we have the function of cos 2x, so okay, I will write first the formula. So the formula is our formula is 1 over 1 minus u squared times du over dx. So substitute the values, so 1 over 1 minus, so our u here is the cos 2x, so I'll write it, let u is equals to cos 2x and our u prime here is the derivative of cos 2x is simply negative sine 2x, since our times the derivative of cos, which is negative sine 2x, and the derivative of 2x, which is 2. So this is another chain rule, which is u is to x. So we have so one 1 times negative sine 2x is simply negative sine 2x over 1 minus cos squared 2x and multiplied by 2, which is the derivative of 2x. So multiply again, so y prime is negative sine 2x times 2 is simply negative 2 sine 2x over 1 minus cos squared 2x. So applying the Pythagorean identities, this is equal to sine squared 2x. So remember the identities of trigonometry function. So y prime now will be equal to negative negative 2 sine 2x, and by our Pythagorean identities, so 1 minus cos squared is equals to sine squared 2x, and can cancel the sine 2x and cancel the exponent 2. So therefore you have now y prime is equals negative 2 over sine 2x, or in terms of cosecant, we can write this one as a y prime equals to negative 2 cosecant 2x. So this is now the final answer. So moving on to our last and final example. So y prime, if y
is equals to the inverse hyperbolic cosine function of secant x. So first is I will write down the formula. So our formula is 1 over the square root of x squared minus 1 times du over dx. So let our u is the function inside, which is the secant x, and u prime is the derivative of our u secant x. So the derivative of secant x is secant x tangent x. So what are we going to do is we will substitute this to our formula, and it becomes 1 over the square root of x squared, which is our x squared here is the secant x. The secant x squared minus 1 times the derivative of the secant x squared, which is the secant x tangent x, and okay, then simplify this one and will become y prime is equals 1 times secant x tan x is simply secant x tan x over the square root of sec squared x minus 1. By using to our trigonometric identities, the sec x minus 1 is just equals to tan squared x. So this will be written as y prime is equals sec x tan x over tan x, and this can the tan will be cancelled out, and our answer so therefore our answer is y prime is equals the secant x. So our final answer is secant x.
And that is the end of this video. Thank you so much for watching, and I hope that you had a great time and learned a lot from watching. Please don't forget to subscribe to our channel.